Hello, everyone. In this clip, I selected some questions and just to give you some ideas about what is expected of you to know by this midterm exam. So I call it a sample midterm. Okay, I have selected questions and for you to practice. Okay, and this is just one of the versions. The first question, suppose that you have this question on your exam. Of course, this question is very familiar to us. So when you, besides answering all of these questions, right, let's do it one by one. As x approaching 0 from smaller than 0, the rule of the function we use is this piece. And then we do by direct substitution, replacing x by 0, and sine 0 equals to 1, so the limit from left of 0 is 1. When x is approaching 0 from larger, and this piece is going to be used, so we chose this, the piece that's applicable for this function when x approaching 0 from larger than 0. So this is a direct substitution again, cosine 0 equals to 1. And because the limit from left and the limit from right is equal, right? So the limit when x approaching 0 is 1. And you can indicate, you don't have to, but this is because the limit from left and the limit from right are equal, and it is equals to 1. Okay, because of that. However, okay, in the past, because this question was given as the quiz question before, in the past, I saw people doing this, okay, selecting different functions. Okay, those are not necessary. Just to put it equals to 1. Okay. F of 0 is when x equals 0, then it's going to be applying cosine function. Don't write cosine x. Okay. Write cosine 0. Okay. In the past, I saw this mistake. Why do I say it's a mistake? Well, it's a mistake because cosine x is the entire curve. In this case, it's from 0 to pi, we apply function cosine x. And now you say cosine x is equal cosine 0. This is the mistake. Okay, so remove that part. Just cosine 0. Okay, I know you may want to indicate is cosine x is being selected. If that's the case, do this. If you really want to write it that way, x equals 0. Okay, which is not necessary. It's entirely unnecessary. But if you just write cosine x there, it's a mistake, and you're gonna lose the point for that one. Okay. Okay. Small things, big difference. Okay. For x approaching pi from smaller. Okay. And obviously, in this case, the function of choice is going to be cosine x. But this time it's a direct substitution cosine pi, which equals to -1. And the second situation, when x is approaching pi from larger than pi, and the function of choice would be sine x. Sine x, so direct substitution, sine pi is equal to 0. And then when limit approaches, when x approaching pi, the limit of this function does not exist because that the limit from left is not the same when x is approaching pi from larger than pi. They're not the same. So all of these is testing you guys about, as I mentioned earlier, about these concepts. Okay, I bring up the flashcards. I bring up the flashcard. Do you guys see that? Let's see. Yeah, you do. Okay. So the flashcard, which part of the flashcards? Limit, right? Definition. One we can direct substitution, one-sided limit, right? And what's the relation between one-sided limit and limit? So this is the flashcard we're testing you guys on. This is a very, very important theorem. Very, very important theorem. Okay. And last but not least, f of pi, we're going to substitute, we're going to apply the function, which is cosine x. So once again, don't write cosine x, write cosine pi. Okay, and that equals to -1. But on this exam, if I give you some question like this, I will add additional questions. The first one is indicate the points of discontinuity by applying the definition, okay, by the definition of continuous function, okay? So obviously this function we are given is a piecewise function, this function. So I'm just going to explain to you why, and then I'm going to give you how you're going to answer this question, right? So first of all, you can see each individual functions, they are all continuous on their domain, and their domain are all real numbers. And of course, we take pieces of them, right? So this f function is continuous where? It is certainly defined everywhere, right? F of x is defined. This function is certainly defined everywhere in the, from negative infinity to positive infinity, right? So the first about definitional function, right? We want you to study the definitional function to answer this question. So what's the definition of function? What's the definition of continuous function? Right here, the definition of continuous function, right? Among the three elements, the first one is satisfied, right? Because it's defined everywhere. It's defined everywhere. And does the limit exist? Right? The second question, then we realize, yeah, the limit does not exist at pi, and the limit exists at 0, right? The limit exists at 0. And thirdly, that the limit, the only 2 points of questions is 0 or pi, right? So we need to study that. Elsewhere, they're all continuous. They're all continuous. No question asked, right? So these are the two points we need to single out to specifically demonstrate to reader that it is continuous or not. We're going to apply this definition to these 2 points. Okay, so let's see how we're going to apply the definition to these 2 points. So at pi, well, let's say at 0, right? At 0, right? The limit at 0 is the same as the value of the function at 0. So at 0, you can say that is equals to f of 0. We just demonstrated, right? We in our work it's demonstrated. And that is the definition of continuous function. Okay? So by this time, this is 3 in 1. Defined, limit exists, and they're equal. Okay, let's bring it. So at 0, all 3 are satisfied. Therefore, you will say f of x is continuous, is continuous as 0. So that one of the questionable points is answered. So from -infinity to 0 and all the way up to pi, we're good. We're good, right? All right. Less than pi. So it looks like that f is continuous. So what we need to do is that look at a pi, right? The limit of the function at pi does not exist, right? This guy does not exist. Thus, f of x is not continuous at pi. It's not continuous at pi. So now, what do we say about the function, the interval or the function where it is continuous, right? So we just have indicate points of discontinuity by definition of a continuous function. How do we answer that? Well, there are 2 points of questionable nature, right? The first one we answered, it is continuous. Okay, the second one, it is not continuous. So the point of discontinuity is what? Is pi. Do we have to answer this part? We actually don't need to. We actually don't need to, because this question is asking us to indicate the point of discontinuity. And that's the only point of discontinuity. Okay? Now, second question. Give the intervals where the function is continuous. This one is more interesting. Okay, because we have this definition in your index cards, right? A function is continuous on an interval if it's continuous at every number in the interval. So far, we know that f of x is continuous on this interval, right? From -infinity to pi, right? And the pi to positive infinity. However, there's this left continuity and right continuity, okay? Left continuity and right continuity. What is left continuity? What is the right continuity? We have a definition on left continuity and right continuity. Okay, so this is the part I need you to apply our definition. So I'm going to put this here. Okay, our continuity here. Maybe I just copy this piece and bring it over to our screen. factoring, right? So we're gonna study this. You need to write, because I'm gonna give you a final answer how to answer this question, the final version. But before that, we have this discussion as how to apply this. Okay, we did this in class, but we didn't do much of homework on it. Okay, but this concept is important because we use a continuous function in the intermediate value theorem. So now let's look at the continuity at a pi. Is it left continuity, right continuity, right? So we get to apply this definition. So at a pi is only point of questionable. That's questionable, right? So what do we have? At a pi, we know at a pi there's no continuity. At f of pi, right? We have these, right? We have these, and f of pi equals to -1. We have these three facts. We have these three facts. Okay? So in order to see this, right? So in order for us to see better, we're going to apply the definition. We're going to apply the definition. So see what the definition say. At a pi from larger than pi is a 0. It doesn't equal to the value of the function at pi. But from left of pi, right? This piece is equal to f of pi. You guys see that? Okay. So from smaller than pi, we have right. Wait. We have left continuity. We have left continuity. Okay. F. So what do we say? F is continuous from the left of pi. From the left of pi, right? Pi is A is pi. That's what this says. If it's continuous from left of pi, by definition of continuous function at closed interval, right? If f is defined only, right? If f is defined on one endpoint, we understand continuous at endpoints mean continuous from the right or the left. Okay, what does this mean? F is continuous from smaller than pi. Therefore, the function is continuous from -infinity to pi, and the interval is going to be like this. There. That's what we mean. I hope you understand that. So this is to follow the definition closely. And this is also a further interpretation. So when we later apply intermediate value theorems on intervals, right? On interval AB, closed interval. Okay, it means what? Okay, we're gonna explain that later, okay? So f is continuous on this interval where pi is included. How about the other one? Is this left continuous? Okay. This is a right continuous and this is a left continuous, right? This is a left continuous, therefore it's continuous on this piece. Is this right continuous? So is it continuous at pi on this interval from right? and the answer is not. Okay, so f is continuous from the left of pi, but, okay, when the limit of the function is not the same, is not as the same as f of pi because it equals to 0. Okay, right? So one is continuous from the left. So we can remove these. Okay, let's clean it up. Let's clean it up. Okay. Left continuous, therefore is continuous from negative infinity to pi. The pi side is closed. On the other side, okay, from right of pi, the function's limit, right, is not the same. The limit is the limit is 0, but the value of the function is -1. Right? We can clean up this one. We can clean up this one. Okay, I'm just gonna make it a little bit cleaner. Sorry. Okay, so now you can see it's left continuous, therefore it's continuous on this interval, but it is not right continuous. It is not right continuous. Okay, so f is not right continuous at pi. Okay, and thus f is continuous. F is continuous on pi to infinity. Okay, so we're gonna reorganize. Okay, yeah, so we got that. So this one was equal to, I deleted 0, right? That was a 0. So we got it, Now, before I give you the final version of the solution, right? Why do I bring up this on the, and want you to study this, right? Because intermediate value theorem okay, states that the function is continuous on a closed interval. Why we emphasize this one so much? And what does it mean? It's continuous. I definitively talk about it, but when we use it, we didn't emphasize it enough, not enough. So you may not be aware of it. Okay. So what does it mean? What is this requirement? What does this requirement mean? Okay, what does this requirement mean? It means the following 3 things. Number 1, f is continuous. F is continuous on the open interval. So it's continuous everywhere. Number 2, f is, okay, let me write it down. F for A is right continuous at A. What does it mean? Right continuous is this condition. Okay, right continuous is this condition, which is limit x approaching A, f of x is equal to f of A. Number 3, f is left continuous at B. Left continuous at B. Left continuous at B. One is right continuous, one is left continuous at B, meaning, right, the limit as x approaching B, f of x, well, in this case, you can only approach B from smaller than B, right? So this is a plus, sorry, this is a plus, and this is a minus from smaller. So that's going to be f of B. So so the reason I bring this up is for you and for all of us to understand the importance of that condition in intermediate value theorem, and also has an understanding of the meaning of being continuous on a closed interval. Is at the end point from A is right continuous, left continuous. Now let's go back. Let's go back to how do we answer these questions, right? These additional questions that we haven't, we did not think of before, but I would put them on the test, okay? So I want you to be prepared, okay? To answer the first question, after all of these discussions, right? After all of these discussions, you understand what I'm saying. So all you have to do, because f is continuous at 0, you don't need to answer that part. We only want you to indicate the point of discontinuity, right? So what you answer? Okay, you just say the limit does not exist. Therefore, f of x is not continuous at A, and the point of discontinuity is pi. That's all you have to say. Okay, you can clean this up. That's all you have to say. Okay, and so this is an additional question. So I'm going to put a little symbol for you, so you got that attention. The second additional question is give the intervals where the function is continuous. Okay, we are going to use the continuity, left continuity, right continuity, because we have determined the pi is a point of discontinuity. So pi is a point of interest. We just look at from the left of pi, right of pi, and then we realize that the function, or x approaching pi from smaller than pi, f of x, the limit is equals to the function's value at pi. So by definition, f is continuous from the left of pi, okay? And thus, then you say the function is continuous. Therefore, f of x is continuous from negative infinity to pi, right? So this is the whole picture from discontinuity. So this piece is the reason that we draw the conclusion that f of x is continuous on the interval from negative infinity to pi, including pi, applying the definition. Secondly, right? We just put this one over here because we already know that, right? So you already have those answers up there, right? So you don't have to put it there. So to answer y is continuous on this interval, that's what you need to say. You need to indicate it is continuous, okay? It is continuous on that interval, okay? All right. And the next one, you're gonna say, f is not right continuous at pi. Okay, so therefore it is continuous on pi to infinity, does not including pi. So this is the reason, because we did a comparison, you don't have to write this answer there, and you don't have to write that answer there. The only thing you need to quote, okay, the only thing you need to quote, we're really just quoting the, we're just quoting the definition, really. We're just quoting the definition. Okay, that is, let me write it down. That is, I know this is new. I might have repeated myself too much. Okay. So to answer the question, give the interval where the function is continuous, right? The interval are these. Y, right? Y, and that's the Y, and that's the Y. Okay, quoting our definition from left continuity and right continuity and this other definition. These are your index cards. Okay, these are your index cards. You don't have to put it on the quiz. These are just for you, for your reference. Okay, and you, on the other hand, just to indicate the points in the index card in our specific situation. All right. So to summarize these additional questions, right? Indicate the points of discontinuity by definition of continuous function. This does not exist, thus is not continuous. There's a point of discontinuity is pi. Okay, that's the answer. Second one, indicate, so after much study, we concluded that these two intervals are the intervals where the function is continuous, and why pi is included on this interval, but not included on the other interval. So that's the end for this question. I hope I made myself clear. Okay. Now, I explained to you the intermediate value theorem that states when f is continuous on a closed interval, what it really implies. What it implies that continuous on the interval from A to B parentheses without including A and B, and at A is right continuous, at B is left continuous. I hope this time when you quote intermediate value theorem, you really know what you're doing. Okay, so you must quote it properly. The second set of questions I selected, the second question, I selected 3 questions. Okay, just randomly selected 3 questions. And these about limits. Okay, and this should not be too hard for you. Okay, and so this will be well, by definition of limit, x approaching 5, we cannot apply limit law. Therefore, we apply factoring technique. So we got x minus 5 times x minus 1. All right. That's because x approaching 5, x does not equals to 5. Therefore, x minus 5 is not 0. if x minus 5 is not 0, we are reducing this function by reducing x minus 5. So we are left with x minus 1. Okay. And then we are from here to there. Actually, I wish to remind you of a theorem I mentioned to you many times over, which is this theorem, okay, this theorem. Oh, no, not this one, I'm sorry, this one, okay, this theorem. The two functions are not the same at only one point A. Okay, f of x equals to g of x for x not equals to A. But both limits exist and the limits are the same. Okay, so this is the theorem we are using. So you see this function, let me put it this way. Okay, I still want you to see the theorem. Okay, I put a little note here. You don't need to put it on the test, but I want you to understand. So how does this function, how does this theorem apply here? Because we see this one as a function f. Okay, and this other function x minus 1 is a function g of x. Okay, these two functions, well, obviously the domain of f, right? Domain of f is x not equals to 5. And the domain of g is all real numbers. So these are two different functions. Even one is reduced to the other, but under the condition that x cannot be 5, right? That's what I was talking about. So these two functions are the same everywhere except at 5. So you can see it is the theorem's situation. And if one has a limit and the other one has a limit, so that's why we get to do direct substitution here, which is just going to apply 5 minus 1, which is equals to 4. Okay, I take this theorem, I single out this theorem out because we use it all the time. We should be aware of it. We should be aware of it. Okay, that's from our index card. The next one, the next part about limit, right? The next part about limit is this it's about this, I would say, two special trig identity. Okay, these two special trig identity. And so let's write down these trig identities, right? So let's find them. Let's find them. I'm sure it should be somewhere in your index cards, right? They are, I think we're getting closer, or maybe we passed. We have passed. There, here, right? So here are the two identities we're using. So I'm going to just bring them over here and bring this over here. All right, and we continue our work. We will continue our work. There. And I just make it a little smaller, right? Because during the test, you have your index card with you. And preparing for the exam is also the opportunity to recollect, right? Try to understand the material Even better, even better. So we are going to apply these two, right? You have the index card. You don't need to write down the index card on the test. I know you have them, right? So you just need to put down the work and make sure you do your scratch paper. If it's a mess, right? So what do we do? Tangent x, sine 2x. Well, tangent x equals to sine x over cosine x. Okay, I'm more or less treated as this as a scratch paper. Okay, if I need to, because I will give you a final version of it. I'll give you a final version of it. Okay, and I want to show you how I was thinking of this process. Okay, so tangent x over sine 2x. So we're gonna bring cosine x with us under, right? Multiply cosine x on top. Multiply cosine x in the bottom, right? So on the top we only have sine x. What is sine 2x? What is sine 2x? Sine 2x is 2 times sine x cosine x. It's 2 times sine x cosine x. As a matter of fact, this question is actually simpler than I thought. Maybe I copied the question wrong, huh? Maybe I copied the question wrong. But anyway, since we're doing this, let's finish. Because you can see sine x and sine x are reduced. I must have copied the wrong question, I think. But that's no big deal. We're gonna pick a question. Okay, sine x and sine x reduced. So we got a cosine x squared x. And this is a direct substitution. This is direct substitution. We didn't get to use the two big identities. I think I have copied the wrong question. Okay, so replace x by 0. So this answer is 1/2. All right. That's the wrong question. Now just make sure that the text question will get to use these two identities. But let's go find them, right? It should be in homework number 4. It should be in homework number 4. I'm going to quickly find another question. I might have copied the wrong question. Okay, because it shouldn't be so easy. Wait. Is it homework number 3? I should know better, right? I should know better. 3? Is it in 3? Yeah. Where would it be? I kind of forget. Nobody's here to help me, huh? 5. All right, this has to be the one. There. All right, I'm sorry. So the question I meant to copy was tangent 6t. 6t. Here we go. Tangent 6t. All right. All right, so let's change to the other one. 6x. All right. Okay, so that question doesn't count, but you know how to do it. If you encounter that question, you know how to do it. Now, what are we going to do with this? Obviously, we cannot do that, the other question, right? So what we can do is, you probably don't want to expand it, right? So what we can do is that we take the limit and over here, right? So it's still going to be doing the sine 6x over cosine 6x. and this is going to be sine of 2x. The trick we use the same, right? We're going to multiply cosine 6x multiply cosine 6x. We can simplify that complex fraction. All right, so the top will have only sine of 6x left. And we got a cosine 6x here. And what do we do, right? So I'm going to do this. Multiply 1 over cosine 6x. So put this on the side. And then on the top, I'm going to divide. To use the first trig limit, I would need a 6x. Right? To use the second one, I will need a 2x. I will need a 2x. But I divided by 6x, I have to multiply by 6x, right? So here, I have to keep the balance. Divided by 6x, I have to multiply by 6x. Divided by 2x, I have to multiply by 2x. So this way, it's algebraically balanced, and the equal sign is justified. Do you guys see that? I hope you see that. Right? And 6x divided by 2x, the x and x are reduced. X is not 0. So in truth, I really just multiply by 3. Okay? So this time I have this limit exists according to the first trig limit. The second one has a limit. And the third one also has a limit as x approaching 0. So now we can apply limit law. The constant 3 is just left outside according to limit law. So I'm going to take limit each individually. Don't drop this limit in this case. Okay, don't drop this limit. If you drop this limit, it will not be true. It will be wrong. Okay, so this step is the result of apply limit law. Can we apply limit law? We can, because we have ensured, we have guaranteed that each individual term we apply limit to, they all have limit, right? So this one has a limit, which is equal to 1, right? So by this time, you can see the individual limit, this limit equals to 1. And that limit equals to 1. And this limit is a direct substitution, right? So x is replaced by 0. So that is equals to 1 as well. So the final limit is a 3. The final limit is a 3. Okay? I apologize for that copy error. Number 3. Okay? Number 3, we encounter this absolute value, right? When we do direct substitution, we know in absolute value case, we cannot do direct substitution. We cannot do direct substitution. So what can we do? Okay, so let's do some algebraic manipulation. All right, we're gonna factor out we can factor out the x squared, right? If we factor out the x squared, okay, I'm gonna put a parentheses there. X squared is factored out. So it's left with 1. And x squared is factored out, we just have 1x left. The absolute value of x squared is a positive, right? We can take it out. We can take it out. So we can take this out of the absolute value, and we can also drop the absolute value. Why we can drop the absolute value? Because, you know, the absolute value of x squared is going to be the same as x squared. Okay? And now we got 2x minus 1. We remove this parentheses here. And we are taking limit from larger than half. We're taking limit from larger than half. Well, when x is approaching 0.5 from larger than 0.5, 2x minus 1 is going to be larger than 0, right? Why is that? So here you can have, I'm going to put a little note here so you can figure this out. When x is approaching 0, so these are the little mathematical tricks you can use. When x is approaching 0.5, 0.5 is half, right? So x is larger than half, right? Because approaching half from larger than half. If x is larger than half, from this inequality, if you multiply both sides by 2, that is, i.e., that is 2x is larger than 1. If 2x is larger than 1, 2x minus 1 is larger than 0, right? If 2x minus 1 is larger than 0, then the absolute value of it, then the absolute value of 2x minus 1 is what? Okay, is the same as 2x minus 1, right? That's why here we're going to replace it because the absolute value of 2x minus 1 is the same as 2x minus 1. Right? So this is to understand. We're just finding the limit from right? So now 2x minus 1 and 2x minus 1 can be reduced. So there is a process. There is a process for us to remove that. Okay? So 2x minus 1, take away the 2x minus 1, reduced. Now we encounter a rational function. We encounter a rational function. This rational function, right, is defined at half because the domain of 1 over x squared is x cannot be 0. X equals to half is well in the domain. So all we have to do here is just substitute x by 0.5 and 0.5 squared under, that's going to be equals to 4, right? Because half squared is 1/4. 1 divided by quarter is 4. So that's the limit we have here. So you can see in this process, it involves the handling of factor, understanding absolute value. And you really have to understand absolute value very, very well to carry out these steps. I hope in this process you understand absolute value very well. Okay. I don't know how much time has passed. Maybe we will we'll take a break. Okay, so let me put a stop to this one and we'll continue on the next one. Thank you for watching.